One of the main outcomes you get with Cisco UCS is a radically simplified server management infrastructure and managing the network for those servers. You can have up to 20 chassis, each with transparent, stateless networking devices, the fabric extenders. So all of the management for the networking for the servers is fundamentally changed with UCS. But also, in addition to that, the upstream networking is different too. Has been simplified with a new forwarding mode called end host mode, and this is the mode that's on by default when you first turn on the system. So one of the things that end host mode does that's very similar to a typical layer 2 switch is the fact that it does local switching for servers that are on the same VLAN. So you can see here we've got server 1 and server 2 on VLAN 10, and any traffic between these servers on the same VLAN will be locally switched by the Fabric Interconnect, just like any layer 2 switch would do. There is MAC learning that happens for all of the servers that are managed by UCS. So server 2 can transmit packets to server 1 through a typical MAC learning lookup. What's fundamentally different about end host mode from a normal layer 2 switch is how the upstream connectivity is managed or handled to the rest of the LAN. So as we can see here, rather than using typical VLAN forwarding logic to determine which uplink a server uses, we're going to use a pinning logic here. So server 2 is pinned to the red uplink and server 1 is pinned to the orange uplink. It's as if logically server 2 is connected all the way up to this LAN switch. Same thing with server 1. So the way that UCS attaches to the upstream LAN is much like a server and not like a switch. So this radically simplifies the way the upstream LAN is configured. We don't have to configure those as ports that are processing spanning tree. We can configure those as server-like ports. So there is no spanning tree processing at all between the Fabric Interconnect and the upstream LAN. This reduces CPU utilization on the Fabric Interconnect. It reduces CPU utilization on the upstream LAN switch. And because we do this pinning logic of server to uplink, there is no need to really learn MAC addresses from all of the devices outside of UCS. So there's no MAC learning at all that happens on the uplinks. If a server in UCS is sending a packet to something that's unknown by UCS, well, we just simply forward it out the pinned uplink. So that is going to help you scale UCS into larger data centers. The 6100 can hold about 16,000 MAC addresses, but with end host mode, those 16,000 MAC addresses, we only need to be concerned with all of the servers underneath UCS. We don't need to size the 16,000 MAC addresses for everything else in the data center like you would have to do with a typical layer 2 switch. Another thing about end host mode is you get active-active forwarding maximum bandwidth on all uplinks. So here we've got two servers on VLAN 10, and both uplinks are forwarding for VLAN 10 for those two servers. This is something that probably would not happen if you had just a typical layer 2 switch with spanning tree. One of those links would be blocking and you would have half the bandwidth. Again, this is because we use the pinning relationship of server to uplink. And this is possible even if you do not have any type of stacking or clustering technology in your upstream LAN switch. You can have a very basic configuration of just two logical switches upstream, and you still have active forwarding, all links forwarding for all VLANs and UCS. So it really helps to maximize the utilization of all your 10 gig uplinks. So UCS end host mode is on by default, and that's because it's the recommended switching mode to implement. All right, let's take a look at some of the unicast forwarding behavior of end host mode. So as I said in the previous slide, in end host mode, we have local switching between servers on the same VLAN. So server 1 and server 2 here are on VLAN 10, and if they're going to have a unicast conversation on VLAN 10, that will be locally switched on the 6100 at the Fabric Interconnect. One thing that is different about end host mode from a typical layer 2 switch is uplink to uplink traffic is blocked. So any packets that come in on this orange uplink will be prevented from getting switched and out up on the red uplink. That is fundamentally blocked in hardware, so there really isn't any chance that UCS could introduce a loop to the upstream LAN, and that is one of the reasons why we can disable spanning tree in end host mode. And as I mentioned previously as well, the servers are pinned to an uplink. So we have server 2 pinned to the orange uplink, and we have server 1 pinned to the red uplink. That's called dynamic pinning. And when that happens, if a packet comes in on an uplink for a server that server is not pinned to, that traffic will be dropped. That's called the reverse path forwarding check. So here a packet has arrived on the red uplink for server 2, but server 2 is pinned to the orange uplink. So that is unexpected behavior. That should not be happening, so that packet will be dropped. Another thing that happens is called a deja vu check. And if a packet arrives on an uplink that is from a server inside of UCS, such as if something was transmitted by server 2 out the orange uplink, and for some reason if it came through the LAN and back down onto the red uplink, the 6100 will look at that packet and say, wait a minute, this came from server 2, it shouldn't be coming in on an uplink here, so I'm just going to discard and drop that packet. Now let's take a look at some of the multicast and broadcast forwarding behavior of end-host mode. Now when you have multiple logical uplinks configured on a 6100 like we have here with the orange uplink and the red uplink, one thing that the Fabric Interconnect is going to do right away is going to pick one of those uplinks as the broadcast listener and multicast listener for all VLANs. So here we have the red uplink, and that was chosen as a broadcast listener. So any broadcast messages or multicast that is received on that uplink will be forwarded down to the servers. Any broadcasts that are received on any other uplink, such as the orange uplink here, those will be immediately discarded right at that port. This obviously is going to prevent the servers from receiving duplicate copies of a broadcast packet. Same thing with multicast. Multicast is also, well, because we are listening to broadcasts on the red uplink, we're going to learn the PIM router on that red uplink as well, and therefore all outbound multicast traffic will also be pinned or forwarded out of this broadcast multicast link. So server 2 here is sending a multicast packet for the upstream LAN, and that will be forwarded out of this broadcast link rather than the orange link that all of the unicast traffic is pinned to. And with local broadcasts from server to server within UCS, those are forwarded normally and locally, just like any layer 2 switch would do. Server 2 sends a broadcast on the same VLAN as server 1. That will be locally forwarded directly to server 1. Now the RPF and deja vu checks also apply here. So when server 2 sends a broadcast message, that will be forwarded out of its pinned uplink. Now the upstream LAN is going to receive that broadcast and is going to forward it on all ports on that same VLAN, which means it's going to forward that same broadcast message from server 2 back down to this red uplink. But the deja vu check is going to apply there. The 6100 is going to see, hey, this is a broadcast packet from server 2 that I'm receiving here, so that needs to be dropped, and it will drop that right on the port. That's the deja vu check. And the reverse path forwarding check, that again is if a broadcast is received on an uplink, on a logical uplink that is not chosen as a broadcast listener, that will be dropped as well due to the RPF check. So up to this point we've been talking about end host mode. Now let's talk about switch mode briefly. When you put the Fabric Interconnect in switch mode, you're basically changing it into a typical layer 2 switch. And it's going to behave like a layer 2 switch on the uplink ports as well as the server ports. You're going to have traffic locally switched for servers in the same VLAN, as well as you'll be running spanning tree on the uplinks to find loops to the upstream LAN and blocking any redundant links. So here we've got server 1 and 2 both on VLAN 10. They are now sharing one uplink for traffic on VLAN 10. We're also going to perform MAC learning on all interfaces. So if you've got a larger data center environment, you might want to think about that before you change the switch mode. Make sure that you don't overrun the 16,000 MAC address table in the 6100. Customers sometimes will switch to switch mode if they have separate upstream layer 2 networks like a DMZ, an internal network, or prior to appliance ports. If you had an appliance like a NAS appliance and you wanted to attach that to the Fabric Interconnect, that was another scenario where you needed to use switch mode. But other than that, end host mode should work for most cases and is on by default, but switch mode is there in case you need it.